Welcome to STEM Baba. In this video, we'll discuss the problem and conceptual exercises of chapter 4 from the book James Walker. So let's start. Now in this question, we are given that a tennis ball is struck in such a way that it leaves a racket with a speed of 4.87 meter per second in the horizontal direction. So this ball is struck in the horizontal direction, and this will be the trajectory of the ball when it reaches on the ground. And the initial speed of the ball is in the x direction, basically horizontal. So v naught x we are given to be 4.87 meter per second. Now when the ball hits the court, it covers a horizontal distance of 1.95 meter from the racket. So basically they are talking about the range. The range is given to be 1.95 meter. Now we are asked to calculate the height of the tennis ball when it left the racket. So this height we have to calculate when it left the racket. This height h. Now first what I'm going to do is I'll find the time of flight, the time taken by the ball to reach on the ground. So for that I'm going to see the motion of the ball in the horizontal direction, and we can use this equation: x is equals to x naught plus v naught x times t plus 1 over 2 ax t square. Now we are taking this to be the x-axis, y-axis. This is the x-axis and this is the y-axis. Now initially x naught, this is 0, and the final position we have 1.95 meter, and acceleration, there is no acceleration, so this is also 0. Finally x is equals to v naught x times t, and from here the expression for t will be x over v naught x. Now this is x, the range basically. Now we can easily find the time of flight from here. So time of flight t will be x is 1.95 and v naught x we have 4.87. So from here the value of t comes out to be as 0.40 seconds. Now we're going to see the motion of the ball in the vertical direction. So for that I'm going to use the equation y is equals to y naught plus v naught y times t plus 1 over 2 a y t square. Now the ball was hit horizontally, so there is no vertical component initially. V naught y, this would be 0. That is 0. Y naught, we have here the y naught is, the position is h, so this is h, and finally it becomes 0. Then minus 1 over 2 g, because ay is minus g here, and t square. So from here the expression for h will be 1 over 2 g t square. Now we have to put the values to find the answer. So h will be equals to 1 over 2, g is 9.81 meter per second squared, multiplied with time we have 0.40 seconds and it whole square, and on further solving we'll get the height to be 0.785 meter. So this is the required height, or the height of the tennis ball when it left the racket. Now in this question we are given that an osprey flies horizontally with a constant speed of 6.8 meter per second. It's flying like this. Constant speed v naught is 6.8 meter per second. When it drops the fish it was carrying. Now we need to tell how much time elapses after the fish is dropped before the speed of the fish doubles. Now let us draw the trajectory for the fish when it is being dropped. So it will move something like that, and suppose that at this position the speed of the fish doubles. So at this instant it will have two components of velocity, one in the horizontal direction and another in the vertical direction, and the horizontal speed will be same as that of this value. So v naught, this is 6.8 meter per second, and what would be the speed in the vertical direction? For that we can use this equation: vy is equals to v naught y plus ayt, right? And this time I think I'm taking this side to be the positive y-axis and this side to be the positive x-axis. So ay in this case we can take it to be plus g this time, because we have considered this to be y-axis. V naught y, there is no initial velocity of the fish in the vertical direction, so this is 0. So Vy, this would be equals to gt. So that would be gt in the vertical direction. Now the speed will be this direction. This would be the speed of the fish, and these are the components, and this would be equals to under root the x component square plus the y component square. We can write this way. Now what they are saying that this speed becomes double of this value, so we can write that Vf is 2 times 6.8 meter per second, right? So we have all the values, we can put it here. So this would be 2 times 6.8 meter per second is equals to under root V naught x, we have 6.8 and its whole square. V naught y, we have gt and its whole square. So from here we can easily find the value for t. So now we can do one thing, squaring both the sides. So this would become 138.72 is equals to 6.8 square plus gt whole square. Take this term to the left side, so this would become negative here and equals, right? Now from here t would be equals to 1.20 seconds. So it took 1.20 seconds for the fish to double its speed. So this is the final answer. Now this question is a very interesting question, so pay attention to it. It says that in a squirt gun contest, a participant runs horizontally with a speed of 7.8 meter per second. Now then she fires her gun in a plane of her motion but 45 degrees above horizontal, and the gun can shoot water at 11.5 meter per second relative to the barrel, and also she fires the gun 0.42 seconds after leaving the deck. So after 0.42 seconds, suppose that she reaches here. So after reaching at this point, she fires the gun at an angle 45 degrees above horizontal. So this would be the direction of the water relative to person. Now what would be the direction of person relative to ground? So this is the direction of person relative to ground. Now there are two parts in this question that we need to solve. In the A part, we need to find what is the initial velocity of water particle as seen by an observer on the ground. Now this question needs the concepts that we studied in the relative motion. So basically the velocity of the water relative to ground, this will be equals to velocity of water relative to person plus the velocity of person relative to ground. So vector summation of these two velocity will give the velocity of water relative to ground, right? Now first I'll be writing the velocity of water relative to person. So velocity of water relative to person. Now he fires the gun at an angle 45 degrees above horizontal, and it also says that gun can shoot water at 11 meter per second relative to barrel. So basically this will be 11 cosine 45 x cap plus 11 sine 45 y cap. This will be the velocity of water relative to person. Now next, the velocity of person relative to ground. Now initially the person was running at a speed of 7.8 meter per second, which will remain constant. The x component will remain same, that is 7.8 meter per second, and the y component will increase at the rate of gt. Thus the velocity of person relative to ground will be 7.8 x cap minus, now why I'm taking this minus, because this Vy is in the downward direction, so that is why minus g times t. Now g, we know its standard value 9.81 and time is given to be 0.42 seconds, because after that much of time he fires the gun. So this t will be multiplied with 0.42, which is equals to 4.12 meter per second. So this would be minus 1.42 meter per second y cap. Now simply we have to add these two vectors to find the the velocity of water relative to ground. So let's add the vectors. So this is the velocity of water relative to ground. So add x component to x component, y component to the y component. So this will be 11 cosine 45 plus 7.8 x cap plus 11 sine 45. This is minus 4.12 and y cap. So after solving, we'll get this value to be 15.6 meter per second x cap plus 3.7 meter per second y cap. So this will be the velocity of water relative to ground, and the answer for the A part. Now next, in the B part, it says that at the instant she fires, the gun is 1.9 meter above the level ground. So this vertical distance h, this height, it is talking about that this is 1.9 meter. Now how far will the water travel horizontally before landing? So the trajectory of water will look something like that, parabolic trajectory. Now we have to find this range x. This is what we have to calculate, this distance. This is what we call the range. So this is what we have to calculate. So for that, we'll be first find the time taken by the water to reach on the ground. For that, we can use the equations of motion in the vertical direction. So this is the B part that we are solving. So y is equals to y naught plus v naught y times t minus 1 over 2 gt square. Now y is the final position for the water, which is 0 on ground, and y naught is 1.9 meter. V naught y is the vertical component of water, which is this 3.7. So 3.7 multiplied with t minus 1 over 2 g is 9.81 times t square. Now it's a quadratic equation, so you can use a calculator to solve this equation, and we'll get the value for time to be negative 0.35 and 1.1 seconds. So this value is neglected, this value will take. So time taken by the water to reach the ground is 1.1 seconds. Now it's pretty simple. The range or the distance traveled in the x direction will be x is equals to x naught plus v naught xt plus 1 over 2 a xt square. Now there is no acceleration in the horizontal, so this whole term 0. X naught is also 0. Now next, x will be v naught x times t. So v naught x, we have this is v naught x, the horizontal component of velocity, 15.6 multiplied with time is 1.1 second, which is equals to 17 meter. Thus the horizontal distance traveled by the water is 17 meter.